So happy to see all of you in another session. Good morning, everyone. So before you, I am presenting the periodic table of elements. You can see all the elements except one. I have concealed one. I hope you may name the compound. Yes, it is correct. It is hydrogen. Since we have seen about hydrogen and its isotopes, orthohydrogen, parahydrogen, and also hydrates, different types of hydrates, everything in previous classes. Just some 4 or 6 slides now. It will be about your checking memory. So that one is hydrogen, and now one element is concealed. Can you say which type of hydride is that? Yes. So is it metallic? Good. It is metallic. So next, another element is concealed. I think you can see, just if you gaze through all these things, you can see in alkali the last one is concealed. What type of hydride is it? So it is ionic hydride. Good. Or for the next, we'll go for the next one. So now you can see beryllium. Beryllium is concealed. What type of hydride is that? Is it ionic? No, it is covalent hydride. You could have seen in previous class. It is covalent hydride. You could have seen the previous images in our previous classes. So this you can see beryllium. Okay. So let us see. Let us continue. Okay. Now I have concealed the other one next to boron. I think it is carbon. It belongs to which type of hydride? Covalent hydride. Good. So now I concealed another element. Have you seen? So it is cadmium. Sorry, palladium. So it belongs to metallic hydride. Good. So let us move to today's class. I'll start the class with a question. So you know the fishes, it lives in water. It won't live in land. So it lives in water. So as like you see, there are three states of matter: solid, liquid, gas. Water is liquid, ice is solid, steam is gas. These are the three states for water molecule. So one state is liquid, in which fish lives only in this state. It won't live in any other state, even in ice or in steam. It won't live. So it will die. So let us take a continent like this, you know. So do you name this continent? So it is Antarctica. Or you can go also to Arctic, those regions. So the north and south poles of the earth. So in this, how does the fishes live? How does? Because everything is ice, it is a solid state of water. How does? So in this, it won't live. Only in water it will live. How does these lives here? Okay. The answer. So you may be knowing the answer. You may also guess correct. If you are correct, you can check with the following further deliberations. So I'll present another one. Another one is this one. So you see, so think you can follow the yellow circled cursor. So where the x-axis, it shows the periods, p block elements. Hydrates of p block elements is taken in x-axis, and in y-axis the boiling point. Okay, so let us see. See, this is oxygen group: oxygen, sulfur, and all these things, selenium, tellurium. And then these are the hydrates. So all these are hydrates of oxygen: H2, H2S, H3SC, H2TE. So likewise, next one, fluorine group, halogens: HF, HCl, the blue line, HBr and SbH3. Okay. So next, this is the nitrogen group: ammonia, phosphine, the green colored, ASH3 and SpH3. Okay. So these are the hydrates of Kleebach elements. It's taken on the x-axis and it is matched with their boiling points. It's taken in y-axis. The elements, the hydrates. Okay. Let us see the boiling. You see all those three lines. One is the red, the other one is the blue, the other one is the green. So in all these things, you could see that the boiling point of the first hydrate of all the groups like water, HF, and ammonia is abnormally high when compared to its counterparts in the same family. You know the family will be exhibiting same physical and chemical properties. Okay, but here there is an exception for the first elements alone in each family. The second family HF, the third family ammonia. So what are these? What is the reason for this? And what is the reason? How does the fishes live in order? So all everything is connected. So everything is connected. What is the answer and where lies the answer? Can you guess? Can you say? I think you could also say many of you can guess. So the answer lies in hydrogen bond. See the abnormal boiling point of water is due to the hydrogen bond. The abnormal boiling point of HF is due to hydrogen bond. Same is the case of ammonia. See, you can see this extrapolated line. This extrapolated line, it comes. If it will be coming if there is no hydrogen bond in water. If there is no hydrogen bond in water, estimated boiling point of water in the absence of hydrogen bond, that is roughly around a little maybe minus 80 degree or minus 90 degree centigrade. Boiling point of water would be like that if there is no hydrogen bond. Okay. So shall we go for today's class? And you know today's class is hydrogen bond. To answer all these questions about features, about the abnormal boiling point of the first hydrate in each family. Okay, all these answers lies in hydrogen bond. Let us go for it. So I am presenting before you the water molecule. So oxygen is there and hydrogen is there. So a hydrogen is attached to a compound which is of electronegative. So there is excess of electronegative. Oxygen is more electronegative when compared to hydrogen. Therefore, what it does is, see the bond between oxygen and hydrogen is a covalent bond. So this is the covalent bond. Where you know covalent bond is formed between two pairs of electrons. Sorry, one pair of electron, two electrons totally. So I think I may change color also because that may not be visible. I have just kept here two electrons. So these are the this red colored is an electrons in the covalent bond, a pair of electrons between oxygen and hydrogen, which had formed the covalent bond. Okay, if this pair of electron, if it is in the middle of hydrogen and oxygen, it will both oxygen and hydrogen will be neutral. But it will be in the middle if the electronegativity of hydrogen and oxygen are equal. These pair of electron will be in the middle of the bond. The shared electrons which are used in formation of covalent, it will be in the middle of the bond if you have the electronegativity of hydrogen and oxygen is same. If it is same, it will be in the middle. But we know that oxygen is more electronegative. Since oxygen is more electronegative, what happens? It pulls the bonded pair of electron towards itself. So what happens? Let us see. So I'll take a eraser and I'll rub it. So I'll rub it and I'll so the bonded pair of electrons, it will be towards the oxygen and it is further away from the hydrogen. With respect to hydrogen, it is the loss of electron. Hence, a partial positive charge is developed. Why partial positive? Why not full positive? Because the electron is moved towards the oxygen. That's all. It is not with oxygen. If the electron acts like this lone pair of electron, if these two electrons, if it is with oxygen, then it will be full positive charge. This will be full negative charge, but still it is bonded. In the bonded, it moves little bit towards the oxygen, thus giving rise to so delta negative charge to the oxygen, and delta positive, which means that partial positive charge for hydrogen and partial negative for oxygen. So there develops. So due to the movement of bonded pair of electrons towards the oxygen gets a partial negative and hydrogen gets a partial positive. It will be there always for this hydrogen, for this hydrogen, for this hydrogen, everywhere. So okay. Therefore, now you see, it's not now a neutral compound. A static charge has been developed. A static charge has been developed due to the movement of the bonded pair of electron towards the electronegative compound. In this case, it is oxygen. Now you can see there is a partial negative charge here and there is a partial positive charge over this hydrogen. Between these two opposite charges, there is an attractive force. And what do you call this attractive force? These attractive force, we call this as hydrogen bond, because always it forms with one of the element in that. Out of two elements here, one is hydrogen, and hence we call this as hydrogen bonding. The other can be anything, any electronegative compound like oxygen, like fluorine, like chlorine, like nitrogen, whatever it is. So the other is variable, the one is constant, the constant one is hydrogen, and hence the bond due to partial charges, out of which one is hydrogen, we call it as hydrogen bond. So this is how the hydrogen bond is developed. Okay. So when the bond strength will be more, can you say the answer? When the bond strength will be more, the bond strength will be more if this is the highest electronegative atom. And what is that highest electronegative atom? It is the fluorine atom. If it is between hydrogen and F, the bond strength will be more. Also depends upon the sizes of the elements here. Also the electronegativity. Okay, let me. So always it may not be with oxygen and hydrogen. It may be with different elements with hydrogen. Here you see. So one is hydrogen, the other one is chlorine. This can be also. This is water molecule. This may be any other molecule like HCl, whatever it is. So if you mix hydrogen HCl with water, you will be having a hydrogen bond. It is not with HH like here. It will be with H and Cl. So it may be also like this. Okay. So now I am presenting before you the electronegative table, a periodic table which says about the electronegativity of each element. You could see. So it starts with 1 here. So 1 for lithium, and you can see 4 for fluorine, which is of the most high. So you can see that it's of more high for fluorine. So therefore fluorine is the most electronegative, highest electronegative atom in the periodic table. Okay. See all those things you can see. So the lowest electronegative may be like this, cesium 0.7. So from left to right of the periodic table, the electronegativity increases. The top to bottom electronegativity decreases. This is the periodic change. As you know, we have read about the periodic table. So the electronegativity from the left to right of the periodic table, it is getting increased. From the top to bottom, it is getting decreased. Okay. So these electronegativity differences, it is used to shift the bonding pair of electron towards the highly electronegative atom. It is farther away from the less electronegative atom, thus giving rise to partial charges over there. Partial positive over hydrogen, partial negative over oxygen, and these partial charges may be used, may be in the maybe in the formation of hydrogen bond. An attractive force between these two charges, partial charges, will give rise to the formation of hydrogen bond. Okay, I think you have understood it, and you can also define it. Good. Okay. So let us see. See, these are the different examples of hydrogen bonding. So I'll show one. See this one in an zoomed condition. So this is with hydrogen fluoride. You can see. So this is the covalent bonded hydrogen fluoride, and this is the strong, the thicker line without a continuous line. This is discontinuous line. So the continuous line is HF. The discontinuous line is, it is, what is this called? This is hydrogen bond. So in this covalent bond, the bonded pair shifts towards fluorine and gives rise to partial negative over fluorine and partial positive over hydrogen. The same will be happening in all these four molecules, and hence there is an attractive force between the partial positive and partial negative, which gives rise to hydrogen bond. Okay. So again, this we have seen earlier. It's about water. This is with hydrogen. Okay, and the third one is in ammonia, and the fourth one, can you name this compound? I shall I see this fourth compound, RC double bond OH. So this one, you know, this is acids. This is also another acid. So it's a general formula for acids, carboxylic acid in organic chemistry. So in carboxylic acid also there gives rise to hydrogen bond. Alcohol also there is an hydrogen bond. Acids also there is. So this is the electronegative element and this is the electropositive element. There is an attractive force between these two, and that we termed as hydrogen. You see here, two acids are joined together. What do you call this two? The two. So if only one is there, what do you tell? It is monomer. If two is there, we call it dimer. If three is there, it is trimer, tetramer. It's etc. It goes like here. Two acids are joining together, then we call it as dimer. So due to hydrogen bond, molecular association takes place. Okay, it may be in two, it may be in three. It may, here in the case of carboxylic acid, it is two, dimer. In some other cases, it may be trimer or tetramer, etc. And it may be polymer also. So here you can see alcohol. In alcohol, this is an acid. Okay. So these are the different examples of hydrogen bonding. Let us move further. So it never involves more than two atoms. Hydrogen bond, it involves only two atoms, out of which what is the one is constant. So it is hydrogen. What is the other one? It is a high electronegative atom such as fluorine, chlorine, nitrogen, oxygen, etc. Okay. So you can see out of this, the continuous one is covalent bond, the discontinuous one is hydrogen bond. So hydrogen bond is the weak van der Waals force of attraction between, sorry, I have to reverse this molecule. One is hydrogen, the other should be fluorine. So I have given in a wrong way. So people kindly change it. So one is the hydrogen, the other should be the fluorine in this. Here we have to invert. So the continuous one is the covalent, the discontinuous one is the weak van der Waals force of attraction between the positive part and the negative part, which was generated using the shifting of bonded covalent pair. See, these are the dissociation energy or dissociation of a bond. Suppose if you want to break a bond, you have to give energy. That energy is called dissociation energy. Suppose if you want to break the bond between hydrogen and fluorine, so it is called dissociation energy. The dissociation energy in case of covalent bond is 50 to 100 kilocalories per mole. And what about these 3 kilocalories per mole? These 3 kilocalories more is the dissociation energy of hydrogen bond here. So what to say? What is the difference? Why the difference has come? Because the covalent bond is so strong Then the hydrogen bond. Hydrogen bond is weak. Since it is weak, it's just enough if you give 3 kilocalorie, it will break. So in case of covalent bond, you have to give 50 to 100. It depends upon the molecule to molecule. But for a particular molecule, it will be constant. Like if you take hydrogen, it will be constant. Okay. For different molecules, it starts from 50 and may go up to 100 kilocalories per molecule. Okay. So the last one which we are going to discuss, the unusual property of water. So in the beginning of the class, I have asked how does the fish live? In case if all the ice or all the water becomes ice, as like we have seen here, the first with that only we have started. So fish lives only in water, and the solid part of water is ice. If all the water becomes ice, as the case like Arctic regions, Antarctic regions, how does the fishes live? Because it may not move, it may not take oxygen. Only if the water in liquid state, water molecule in liquid state, only this will survive. So how does this survive in all this stream? So let us look it further. Let us go further to answer this question. So this is the water molecule where the red is oxygen and these white spheres are hydrogen, and that you call oxygen and hydrogen, you call it as covalent bond whose length is 1 angstrom unit. Here you see between oxygen of another molecule, hydrogen of another molecule, that forms a hydrogen bond whose bond length is 1.76 angstrom unit. So you can see almost twice the length. So if it is 1 angstrom, it is more than 1.7, it's almost 1.76. Roughly you can take it as 2, which means that there is almost twice the distance between the oxygen and hydrogen, between these oxygen and hydrogen of another molecule. So this is hydrogen bonding. So the one goes for hydrogen bonding between two different molecules in water. Okay. So I am telling about this in liquid state, like if water is in liquid state. Suppose you take water forms, when it goes to solid state, everything it will be like this. If it is a solid, it will be like this. So where the bonds become more nearer, it comes very close. It will be hexagonal shape. So it will be in hexagonal shape. So these are different molecules brought very near in case if it goes to solid form. If it goes to solid form, the hydrogen bonding degenerates. Hydrogen bonding will be very less, far less, because because of the because everything it is formed in a tight fashion where the molecule does not move. It won't be moving for it is one molecule is being tied to another molecule. There is the less formation of hydrogen bond, and it will be still closer like this. All those water molecule. So it's very tight. It's very close. Okay. See just one correction here. So if it is so you see, so if hydrogen bond exists in a water molecule like this, you see how much gap is there. These gaps may not be there when it goes to solid states. When it is in liquid state, due to hydrogen bonding, these gaps are there. You can see the gaps are there. Because of the presence of these gaps, okay, the density of water is more than the density of ice. Okay, so ice is lesser denser. Ice is lesser denser than the water. So this is unusual property. This is the unusual property of water where always for a solid will be dense. You take anything. So iron liquid, iron vapor. Whatever magnesium solid, magnesium liquid, magnesium gas. Whatever you take, the solid will be always denser. But in case of water alone, the solid part is less denser. It is very less denser, and since it's very less denser, it floats over the liquid water. Suppose you take Arctic and Antarctic regions. So since ice is less denser, it floats over water, and below which you will see full water is therefore the fishes are alive. Below the ice, there will be always water. Since it is the ice is less denser, it will be floating over the liquid water. That is why the the sea animals are surviving even in Arctic and Antarctic region. Okay, this is the answer, and also this is why the unusual property, because of the presence of hydrogen bonding. So now we will look into another types of hydrogen bonding. There are two types of hydrogen bonding. If you look into these two molecules, so let me break here. So if I break here, you can see this is one type of hydrogen bond. This is yet another type of hydrogen bond. This is nitro group. This is OH group. If only OH is there, it is phenol. Since nitro is there, it is ortho nitrophenol. So there is a hydrogen bond within a molecule. Here this is paranitrophenol. This is also paranitrophenol. The hydrogen bond is between one molecule and another molecule. This is one molecule and this is another molecule. Okay. So there are two types of hydrogen bond which you can see. One we call inter and another is intramolecular hydrogen bond. Inter means between. So this. Inter means between and intra means within. Okay. So these are the two different types of hydrogen bonding. Orthonitrophenol melting point is -214 and meta and paranitrophenol it is like this. So we have two types of hydrogen bond. One is called inter and another is called intra. Inter means between and intra means within. So many examples are there, but I am showing you one example. So what are the significance of hydrogen bond? So shall we guess? So it is about where we have seen previously by taking the class of the hydrates of p block elements, high melting and boiling points, association between molecules. We have seen carboxylic acid. The third is polymerization. So if there are more than two or three molecules, it goes for polymerization. If infinite number of molecules, it will be polymerization. That occurs in case of amino acids and our DNA. So let us see, these are the DNA strands. So where amino acids in which hydrogen bond is there. So this is a full molecular strand and it is a polymer. So it is alpha helix and beta helix of DNA. Okay. So now it's just a revision. Whatever I have said before, it will be in worded form. Whenever a molecule contains hydrogen bond linked to a high electronegativity, this attracts the shared pair of electrons more. So the end of the molecule becomes slightly negative while the other end becomes slightly positive, partial negative. The negative end of one molecule attracts the positive end of other molecule. As a result, a weak bond is formed between them. This bond is called hydrogen bond. As a result of hydrogen bond, a hydrogen bond links the two electronegative atoms. I may have one is the covalent, the other is the hydrogen bond. Okay, just we have seen before, just in word form. Again, this we have discussed, but I have given words. The molecule must contain highly electronegative atom linked to hydrogen atom. So it's like this. The higher the electronegativity, more is the polarization of one, like F and H. The size of the electronegative atom should be small, so this the attractive will be more. The smaller the size, the greater is the electrostatic attraction. Already this we have discussed. This is a weak bond. The strength of hydrogen bond is intermediate between the weak van der Waals bonds and strong covalent bonds. The dissociation energy of hydrogen bond depends upon the attraction of the shared part of electron, hence the electronegativity of the atom. Okay. Already this we have also discussed. Just I am summarizing. Effect of hydrogen bond. We said about the association, about the carboxylic acid. And since it is dimer, if we find the molecular weight of that compound, it will be double if it is a dimer. If it is a trimer, it will be triple by an experiment. We have to divide it by 3 to get a molecular weight of single compound. we have done by through Ross method or some method. If you find the molecular weights, it shows the value as double if it is a dimer. Also, we have seen this through graph also, high melting and boiling points, and few more which I haven't discussed, but I'm taking here volatility. As the compounds in a hydrogen bond, the different molecules have high boiling points, so there are less volatile. Since the boiling point is high, the volatility is less. You compare with of petrol. Petrol is highly volatile. Okay, but if a hydrogen bond is there, it will be the compound will be of less volatile. So again, viscosity and surface tension. The substance which contain hydrogen bonding exists as an associated mass, so their flow becomes comparatively difficult. They have higher viscosity and higher surface tension. So due to the presence of hydrogen bond, the viscosity and surface tension will be high. Okay. So this one here, in the case the low density of ice than water, which we have explained a little before. In the case of solid ice, the hydrogen bonding gives rise to cage-like structure of water molecules. As a matter of fact, each molecule is linked to tetrahedral to 4 water molecules. The molecules are not closely packed. When ice melts, the structure collapses and more molecules come closer to each other. Thus, the volume decreases and density increases. I think, have you understood? That time also I explained. If it is not clear now, it is also it will be clear in this explanation. My photo also would be there here, but anyway, I will read once more. This in case of solid ice, the hydrogen bond gives rise to a cage-like structure of water molecules. See, I will show that cage-like structure. So this is cage-like structure. If this is cage-like structure of few molecules, this is cage-like structure of large number of molecules. Since cage-like structure is there, there will be fewer molecules per unit volume in case of ice. So if you take ice, if cage-like structure is there, there will be fewer molecules in per unit volume. Therefore, the density is less. Suppose if you break it, if you melt ice, it becomes liquid. There will be no cage-like structure. So more number of molecules will be in per unit volume. Density is nothing but per unit volume. Therefore, since more molecules are there per unit volume, density of water is more than the density of ice. Okay, I think it will be clear now. Okay. Since more number of molecules per unit volume, the density of ice is lesser than the density of water. Okay, hence the solid floats over its own liquid state. Then solubility. Alcohols are soluble in water because of hydrogen bonding which takes place between water and alcohol. So if you take alcohol and water and if you mix it together, thoroughly it mixes because there exists a hydrogen bond between water molecule and alcohol molecule. Since the solubility increases by the presence of hydrogen bond. Thank you.